Hello students, today I am going to explain the concept of molar volume. Okay, so we know moles equal to weight by molar mass, right? Here for molar volume, moles equal to volume by molar volume. Moles equal to weight by molar mass. Here when we come to the gases, this is applicable for gases only, right? This is applicable for gases. Moles equal to volume by molar volume, right? So here one important point is 1 mole of any gas, 1 mole of any gas at STP occupies 22.4 liters. 1 mole of any gas at STP occupies 22.4 liters. Here what you will do, suppose if you take CO2 molecule, SO2 molecule, gases only, right? Or gases or whatever it is, SO2 molecule, and I will take H2 molecule, right? I will take methane molecule, right? For these molecules, I am going to calculate moles in terms of molar masses. I am going to calculate the moles in terms of molar masses, and I am going to calculate moles in terms of molar volume. Suppose all these are 1 moles, right? CO2 moles is 1 mole. I have taken like this. Assume that SO2 is 1 mole. I have taken, right? I have taken 1 mole. I have taken 1 mole of hydrogen gas. I have taken 1 mole of hydrogen gas. So this is the formula for mass and molar mass. This is the formula for volume and molar volume, right? I have taken 1 mole. I need to calculate the weight over here. I need to calculate the volume over here. Observe carefully, right? Everything is 1 mole. I need to calculate weight over here. I need to calculate volume over there, right? First I will calculate the weight. So N equal to W by M, mole equal to 1 mole. I need to calculate the weight. The molar mass of CO2 is 44, right? The molar mass of CO2 is 44. Carbon is 12. Oxygen is 32. So 44 it is coming. So the molar mass of carbon is 44. So what is the weight of 1 mole of CO2? What is the weight of 1 mole of CO2? 44 grams. What is the weight of 1 mole of CO2? 44 grams. Come to here. Now I am calculating the volume, right? So I am going to use the formula. CO2 mole we have given. We have taken 1 mole, right? So we need to find the volume. What is the molar volume here? Here molar mass you are keeping 44. But in the question paper setter gives in terms of the volume. What is the molar volume? 1 mole of any gas at STP occupies 22.4 liter. 1 mole of any gas at STP occupies 22.4 liter. So I will put 22.4 liter over here, right? So the volume of CO2 is 22.4 liter. Understood now? So the weight of the CO2 is 44 grams. And STP conditions, the volume of the CO2 is 22.4 liter. Right? Understood? Now I am going to SO2 molecule. So I am first calculate the mass. Right? 1 mole. That's why I have taken N1 here. I need to calculate the weight. Right? SO2 molar mass is 64. Sulfur is 32. Right? Oxygen is here 32. So 64 is coming. Sulfur mass is 32. Oxygen mass is 2 oxygen atoms, 16 into 2, 32. So 64 is coming. So I have taken the molar mass of SO2, 64. So weight 64 grams is coming. Right? Weight 64 grams is coming. Now I will calculate for SO2 molecule. Moles 1 has given. So volume I need to find. So here what you are going to write? So here for CO2 you have written 44. For SO2 you have written 64. What you have going to write? So what I told you, 1 mole of any gas at STP occupies 22.4 liter only. Whether any gas, X gas, Y gas, CO2 gas, SO2 gas. If he mentions gas and STP means you need to write 22.4 liters for molar volume. So here 22.4 liters, right? So volume of SO2 equal to 22.4 liters. See, here mass is changing. Mass is changing. But here the volume is not changing. 22.4 liter, 22.4 liter. I think now we understood this about with the relation to these two formulas. Now we are going to calculate for H2. H2 I am taking 1 mole, right? So weight we need to calculate. The H2 molar mass is 2. So we are getting 2 grams of H2. 2 grams of H2. So I rub this and I will solve here for hydrogen. Okay. For hydrogen 1 mole we have taken, that's why I am putting 1 over here. We need to find the volume. We need to find the volume of hydrogen. Here what we need to put? Molar mass, molar volume for hydrogen. What we need to put for molar volume for hydrogen? 22.4 liters only. Why? Because 1 mole of any gas at STP occupies 22.4 liters. So if you calculate molar volume for hydrogen, so volume for hydrogen 22.4 to 22.4 liters is coming. CH4 also same. If you calculate weight of the CH4 will come 16 grams, right? But volume of the CH4 will come. Volume of the CH4 will come 22.4 liters. 22.4 liters. 1 liter equal to 1 decimeter cube. 1 liter equal to 1 decimeter cube. So we can also mention 22.4 decimeter cube. 22.4 decimeter cube. I think now understand, you got a clear idea between these two equations. What we need to take when we calculate molar mass, right? What we need to take when we calculate molar volume. Now I will jump to problems, right? And I will do comparatively. Thereby you will get a clear idea. Okay. Take two problems. I am going to take one problem. C plus H2, right? C plus 2H2 or CH4. You also say C plus 2H2 is raised to CH4. I'm going to solve this question for you. Then you will get clear idea about molar volume. Okay. So this is the question. In this question, he asked us to calculate the mass of the methane. In this question, he asked us to calculate the mass of the methane when 24 grams of carbon is taken. In this question, he asked us to calculate the volume of methane when same 24 grams of carbon is taken. For this question, only one change here, mass of the methane, here volume of the methane. Now I am going to solve this. Finally, I find the mass of the methane over here. I find the volume of the methane over here. Right? First write carbon, hydrogen, CH4. Okay. Here 1 mole of carbon, 2 moles of hydrogen, 1 mole of methane. So these are the moles. The stoichiometric coefficient we can directly take as moles. Here also do the same. Carbon, hydrogen, CH4, 1, 2, 1. Right. What is the next step? We need to convert the mass into the moles. So we need to convert the mass into the moles. Here carbon mass is given. So we need to convert the carbon mass into moles. For that, what is the formula we have? Moles equal to weight by molar mass. So N equal to, what is the mass of the carbon given? 24. Molar mass of the carbon is 12. So we have 2 moles, right? 2 moles. Observe carefully. As per the equation, for 1 mole of carbon, 2 moles of hydrogen required. Here for 2 moles of carbon, 4 moles of hydrogen will be required, right? Here for 1 mole of carbon, 1 mole of methane is producing. Here for 2 moles of carbon, 2 moles of methane will be produced, right? Now I am rubbing over here. I will write the moles, these final moles over here, right? What are the final moles we got? 2, 4, 2. And this is the final step. What we need? We need to calculate the mass of the methane. So we have moles. We need to calculate the mass of the methane. What is the formula to convert the moles to mass? So again, moles equal to weight by molar mass. Here moles of the methane is 2, right? Weight we need to calculate. The molar mass of methane is 16, right? How it is 16? CH4. Carbon mass is 12. Hydrogen mass is 4. So it is 16. So weight is 32 grams. 32 grams. So this is the mass of the methane and 24 grams of carbon involved in the reaction. Now we need we calculate the volume of the methane. We calculate the volume of the methane. So again here, carbon, write the moles 1 to 1. He has given the weight of the carbon. So right over here. So weight of the carbon is 24 grams. We need to convert into the moles. So what is the formula we have again? N equal to mass by molar mass, right? So he has given 24 grams of carbon. Molar mass of carbon is 12. So again we are getting 2 moles. Again we are getting 2 moles. For 1 mole of carbon, 2 moles of hydrogen is required. Here 2 moles of carbon, 4 moles of hydrogen is required. For 1 mole of carbon, 1 mole of methane is producing. Here for 2 moles of carbon, 2 moles of methane will be produced, right? I am rubbing and writing the final moles over here, right? What are the final moles over here? 2, 4, 2. Till here everything is same. For these two problems, till here everything is same. In final step we are going to change. Here we have converted the moles into the mass. Here we have converted the moles into the mass. Here we are going to convert the moles into molar volume. Here we are converting to the moles into volume, right? So what is the formula we have? N equal to, right, moles by volume by molar volume. I repeat. Here we are converting the moles into mass. Here we are converting the moles into volume. So what is the formula to convert the moles into mass? Moles equal to weight by molar mass. Here what is the to convert the moles into the volume? N equal to volume by molar volume, right? So first what is the moles we have? Here 2 volume. So what is the molar volume of any gas at STP? 22.4 liter. So the volume of CH4 is, right, 44.8 liter, right? See, so this is the mass of the methane is 32 grams. Volume of the CH4 is 44.8 liters at STP.